Hi everyone, we're going to be getting started here in the next couple minutes. We're going to be viewing BobCam for Rhino, version 3 that's out now. We're going to be viewing the 3-axis milling package today. Just want to make sure everything is going smoothly here. Let's see. Sharing screen. Core taper, interesting. All right, yeah, so I'm making sure that I've got the screen pulled up here. I've got Rhino version 3 open. Got a part file here to be viewing the 3-axis milling. And my name is Eric. I am the BobCAD demo tech. So I normally do demonstrations of the software program for customers and for potential customers of BobCAD. And I'm also doing support technician tickets for anyone having trouble with the software program, anyone having any questions as well, able to help with that as well. I don't see my screen in the preview, so I'm just going to double check here. Make sure you all can see it. Let me know in the chat if you're able to see my screen. I don't see the preview on my side. Just want to make sure I've got everything going on correctly here, and then we'll get started here in the next couple minutes. Going to be going over some of the... Okay, yeah, you guys are saying black screen also. Let me try again here. Chrome tab. Do entire screen with this one. Maybe not. Let me try this. Window. And yeah, that's not it. That's the oh, let me try. Silent stream and see it. Sorry, let me get this view set up for you guys, and then we'll get started here. We'll be going over BobCam for Rhino version 3 today, the 3-axis milling package. me. There we go. Some kind of new settings here with the Vimeo streaming. I think we've got the Bobcam program streaming now. Let me know if you guys are able to see that. Then we can get started here. We have webinars every Wednesday from 1 o'clock to 3 o'clock in the afternoon Eastern Time. And we normally go over, continually different different versions of Bobcat, where we have our standalone. We're up to version 35 for that one. We just finished with a few different weeks of V10 Bobcam for SolidWorks. We were running through the 2-axis milling all the way up to 5-axis milling, and we just started, I believe, last week with the Bobcam version 3 for Rhino, the 2-axis milling, and now we're getting into the 3-axis milling today. All right, looks like you guys said in the comments you guys are able to view my screen. Thank you for letting me know there, Bob. And if you guys have any questions in the comments section, I will try to answer them as we go along. If I'm stuck on a certain topic, I will answer them as I can, or answer any questions at the very end if I don't get to you in a certain time manner there. All right, so yeah, we've been waiting here for a few minutes to see if there's any other stragglers to view the webinar today. So again, my name is Eric. I am the demo tech for Bobcat Cam. So I do demonstrations of the software program for any potential customers and any customers that are interested in viewing any of our modules of the software program. I'm also in tech support, so any questions that customers have running through the software program, or any issues that they have, they can call in and answer any questions that you guys have there. So let's get started here. We have a 3D model here in Rhino 7 that I'm in. You can also be working in Rhino 6 if you have that. Our plugin works for those versions there, and then any newer versions in the future there of Rhino. And when we install Bobcam for Rhino, you'll see up here at the top the different tabs for Rhino. When you're creating your drawing and creating your solid model, you can go up to the top and go to Bobcam and show Bobcam. That will show the cam manager here, where you have your cam tree. You're able to create a new job. We also have our Bob Art tab. That's where you can load an image and you can vectorize an image, meaning you can create a drawing automatically from an image here in this tab for Bobcam. And you also have your data entry box. So whenever you're selecting geometry, it goes to your data entry tab here to so for any data entry for selecting geometry, selecting top of the operation, the total depth you're doing, that's going to be in your data entry tab whenever you're modifying anything or creating any information here in Bobcam. So those are the 3 tabs that we have in BobCam here, and we'll be going through some of the new features here in our 3rd iteration, version 3, BobCam for Rhino, and going through the 3-axis milling package. We'll start by creating a new job for anyone just kind of getting a feel for the plugin for Rhino. So you've got a drawing or a 3D model here in Rhino. You can go to your cam tree. You would right click on cam defaults here and go to a new job. You can select what job type you're doing. We're going to be going through milling today. We also offer turning, mill turn, that's for a lathe with live tooling, and wire EDM. We support wire EDM machines, 2 and 4-axis cutting. Under milling, we offer 3-axis milling machines as well as 4-axis and 5-axis milling. Within the milling job type, we also offer laser, plasma, and water jet machine cutting as well. Programming for those machines. Here we'd be selecting our Bobcat 3-axis mill, and we can go to our stock wizard. We can define our workpiece, so we'd be defining our finished 3D model here. We can define the stock that we're starting with, so whether it's rectangular, like this here, if it's a cylindrical piece of stock, we'll calculate that for a second. It'll create a bounding cylinder, so like the bounding box of the rectangle, it'll create a cylinder around the solid model that I have. There we go. And then we can select which direction the cylinder is going. It's going extruding in the Z direction here. Can change the extrusion direction to the Y-axis, which would look a little better pertaining to my 3D model. Of course, it'd be more of a rectangular shape for this one. I can extrude it out from wireframe. I can select an existing solid model as my stock there. I can also revolve around a stock shape from any wireframe, so I can create a revolved surface or a revolved solid from that. And then I could also select an STL model. So if I select the STL model from my library, from my certain folder that I've got, I can select it from there as well. So I'll go back to the rectangular stock shape, recalculate it there. I can change the dimensions, make it larger in the X direction, larger in the Y, and then taller in the Z direction. You can also set certain offsets. So it looks like this is in millimeters. So if I did like an extra 20 millimeters in the positive X direction, 20 in the Y, 20 in Z, you can see all the different, you can see it adding to each different side there with the offset options. And then my last page is the machine setup. This is where we're defining our work offset at for G54. So if I'm setting a different G54 here, I would highlight this origin box and click on a certain point that I'm selecting my G54 for, and then set my X, Y, and Z directions. So I can highlight the X direction, select a point or a line going in that certain direction, highlight my Y direction, select a point or a line going in that Y direction, and then Z direction would be relative to those 2 arrows. I could also reverse the directions with this arrow to the right here. So once I've set up my G54 on this piece of stock, I'm going to go to my my existing milling job that I have set up. Make things convenient for me where I've got all the milling operations set up here. And everything is blanked out. You can see on the left-hand side where you have this icon of an eyeball with a line through it. If I click on one of the icons, it will show my stock here, for example, or I can hide it again. I can show my machine setup with all the features under that machine setup. It will unblank them, and then I can go to each feature or expand each feature and go to each operation and show the toolpath for each operation from there. So from here, we can create a new milling operation by right-clicking on Machine Setup 1 and going to the different categories here. We have mill drill hole, mill tap hole, counterbore tap operations. Mill 2-axis will give us any 2.5-axis milling operation. It offers a profile roughing, profile finish, pocket, facing, engraving, chamfer mill, corner rounding, all the basic operations there for 2.5-axis machining, where the tool will theoretically go down in Z first, then it'll move in X and Y, and then if it needs to go to the next depth, it will go down in Z, and then move in X and Y. So it's not 3-axis simultaneous for these operations. It's just going down in Z and then X and Y, and then Z again, and then X and Y moves. So that's our what they call 2.5-axis machining. Then we'll get into the 3-axis simultaneous cutting. So if I right-click on Machine Setup 1 and go to Mill 3-axis, if I go to my machining strategy page again, we have our available operations, where we have a 3-axis roughing operation under our advanced rough. Let's see, some finish operations, advanced Z-level finish, following along curved surfaces. Flatlands would detect all the flat areas on a 3D model and finish those with a flat end mill. Equidistant would start from a boundary and then offset to the center, or start from the center out to the boundary I select, and give us kind of a spiral toolpath, giving us a better finish cut with that here. Planar would follow along the surfaces I select and just follow across back and forth. Pencil to mill any fillets, and project curves where I can project a 2D shape onto a 3D surface to do a 3D engraving operation. Suppose we could start with a steep shallow here. This is another finish operation that is newer in the software program, which is similar to the Z-level finish, which is doing the tapered walls here. But with the Z-level finish, it doesn't finish the flat areas normally. So with the steep shallow, it kind of gives you the best of both, where you've got your Z-level finish and your planar toolpath for any flat areas, or your Z-level finish and equidistant to spiral, or do an equidistant toolpath along the flat areas of the model here. So basically 2 in 1 there, your Z-level finish and your planar, or your Z-level finish and your equidistant. Then you've got all of your parameters, lead in, lead out, and different options there, as you would with one of those finish operations. Before we get to our new settings, just want to see if everyone's good. Okay, no questions there. Take a look at we'll be taking a look at our different new options there in the 3-axis milling for version 3 BobCam for SolidWorks. Now, if you looked at the page that you're on here, the What is 3D CAD CAM, it kind of explains there what I went over, and then it will also go over, there's another handout for for the new features And that includes, go to it on my side here. So that includes some key topics: start point control. I'm going to be going through. I'm going to start with some of the template options that we have first. Uh, Toolpath patterns, work offset patterns, job templates, stock and workpiece selection. I think we mainly went through that already. The stock and workpiece selection, I showed you how to define the stock, and then the workpiece here as well. Also here in the CAM tree, we have a fixture option. So I define this as my workpiece, and I can define this bottom solid as my fixture under the machine setup one. If I right click on fixture, I can go to reselect and select any solid models for my fixture, any clamps, any the vise, soft draws that I'm using, so that I can see that in simulation as well. Other than that, what I did with this 3D model is we went through a pocket operation, or you could do a drilling operation. Yeah, I did one here. But I did a pocket operation down inside the areas here. Next is a pocket operation and profile finish for these handle shapes in here. And the way we did an open pocket for this here is in the 2-axis. We're going to the pocket and profile finish. In our geometry selection, when I selected my geometry of the wireframe or of the surfaces, we have this checkbox, detect open edges. So I can check that box, and that's our open pocket feature here.
Hey, Eric.
Yeah, go ahead, Al.
How we doing today?
Good. How's it going?
It's going all right. Going all right.
Yeah. So
Looks like we're on another weekly live, right?
yeah. So just going through some of the basic settings here in the part file that we have, and just about to get into like the template options and newer 3-axis options that we've got here too.
I think that's great. It looks like we have a couple people with us here today. Do we know if any of them are running Bobcam for Rhino?
That is a good question. Yeah, seeing it. Haven't gotten many comments yet, but yeah, good question to ask for you guys in the audience. If you'd like to comment in here, what versions you have of Bobcat, if you do currently have Bobcam for Rhino version 3. Good question to ask there.
Yeah, and I think something we should share as well is that whether you're a Bobcat customer, a Bobcam for SolidWorks, or a Bobcat for Rhino, all three systems now have the same functionality. It's
Right.
shared across the board because of our new Omni development strategy. So, Bob, if you're running 35 and you also are a Rhino user or a SolidWorks user, you'd be able to uh, implement the same functionality that we're showing here as far as the cam goes.
Right.
Okay, so that's important. Some of the other things that we really want to focus on today has to do with some of the basic 3D stuff and new features that we've added. Okay, so whether you're a Bobcat for SolidWorks, or Bobcat for Rhino user, all these feature apply.
Mm-hmm. Yeah, good point. Yeah, so although we're in Bobcam for Rhino today, whether, like you said, whether Bob's in version 35, any of you other guys are in different version of Bobcam for SolidWorks, all of these settings that we're going over, the new features, they're all in the new plugin and standalone as well.
Great, great.
Um, Anything else for now there, Al?
I don't. Can you hear me currently? Let's see.
Yeah, I can hear you well.
Okay, just want to make sure. No, I think we want to keep going, but one of the things that I would touch on definitely is just some of the selection tools, right? So anytime you're in a CAD package, it looks like Dan's got 35 and 4-axis. So Dan, make sure to come back next week because In the coming weeks, we'll have 4-axis that we're covering, I think, the last week of this month. But like any CAD package, understanding selection, it's very important. And there's some things in Rhino that I know for me was a little bit difficult getting used to because it was different, right?
Hmm.
Eric, I'm sure you would agree.
Yeah.
So the control shift function I thought was very useful, especially when we're working on boundaries, you know.
Mhm.
But maybe before we get into some of the 3D stuff, Eric, could you open up one of those SolidWorks files?
Sure.
And the reason why I want to go in this direction is, SolidWorks is a primary CAD package. So if you're utilizing SolidWorks or you're getting SolidWorks files, whether you're working with our standalone or the Bobcam for Rhino, you can bring those files in and work with them. Okay.
Mm.
So regardless of where your design comes from, whichever CAD cam or cam system you're using, you'll be able to work with files from a variety of different uh, primary systems like SolidWorks. Okay.
Right. Right.
Now, one of the things that I think is cool with Rhino as well is when you open up these files, it'll give you an option if you want to map your Z as far as the way that they come in. Is that are you able to see it? Okay, let me let's see if I can just see if I can request
I don't know if you're. I don't see any request option yet. Oh, here we go.
okay.
Like to screen share. Okay.
Let's see. Let's go to this one here. Let's see. Is it displaying now?
Not on my side. Hold on 1 second.
If any of the
There we go.
it looks like it came up. Okay, great. So just kind of as a recap for last week, where we covered some of the 2D features and enhancements that have been added into the software. Again, we're talking about file translators, so you can communicate with really packages or any primary systems, whether you're in the standalone or in the Bobcam for Rhino. Now, there are some advantages of being in Bobcam for Rhino, specifically for the CAD functionality, because we found that it works great with meshes and it's very good with surfacing. So it's a great partner product for CAD. So if you Rhino users, if we're wrong about that, please let us know. Please comment what you like about Rhino for design. Now, again, because the CAM systems are the same across the board, some of the changes that we've made here for 2D that would apply to everybody, or things that are really important to talk about. What would you say one of them would be, Eric, as far
Um,
as 2D machining?
with 2D machining. Well, I think one point that you made that was really good was the mesh files. First of all, being able to go from an STL file in Rhino and be able to create it as a solid model, so that you can pick surface edges and be able to modify the 3D model from an STL file very well in Rhino. That's something that
The
I
CAD,
think.
you're talking about the CAD here.
Yeah.
Rhino's strength for CAD is being able to edit STLs. So for any Bobcat customers that edit a lot of STLs, Rhino may be a good CAD choice for them to consider. But again, the cam's going to be the same across the board. In this
Yep.
case, we have a cavity, right? Like this could be a mold cavity where it's just some simple pockets and some shapes here, right? But on the back side of it, we have some holes that we need to machine. And really, whether you're doing 3D machining or any machining, it's very common to deal with holes. So, Eric, what are some of the new features we have that would help with holes?
Um, would that be the new start point option?
I
What you're
definitely
referring
think the
to?
start point control
Yeah.
is a good one. Let's talk about some automatic toolpaths to begin with. We have the stock set up here, right? Or let's see, I don't have the stock set up yet. So let's get some stock set up on the job, right? And we'll get a 0 set up. So, I want to like invert the Z, like you said, and you can come in here and align your X or Y to be able to adjust which way things are pointing, right? So this is how you adjust your coordinate system and how that coordinate system relates to the orientation of the part. Okay.
Mhm.
So we do that. Okay, so now what are some of our automatic tool paths? Ones that, because we're in 3D now, right?
Mhm.
That the software is going to pick up automatically for us.
Yeah, so we have a new hole recognition option
Where's
for
that?
solid models. So if you right click on the machine setup, I think it's second or third one down, hole recognition, you're
Okay,
able.
so Eric, whole recognition, you know, you need a model for that, right?
Right.
Okay, so anybody who's designing with 3D models and are working with solids and are drilling holes, is this a feature you would recommend?
Yeah, definitely. Save you a
Why?
lot of time. It'll save you a lot of time with different holes on a solid model, so that you don't have to go through creating multiple features and selecting the different size holes for each feature. This one will group all of the holes, and then you'll be able to set the certain depth of each one and many of the other settings that you need there for them.
I would definitely agree. This is an amazing addition to anybody's workflow where they can use the model to pick up different size holes and different types of features. And that's different than previous versions where things like counterbores weren't automatically identified. Um,
Mhm.
Eric, we can adjust the rules too, right? So if we want to change how holes are processed, we can customize that.
Right. Yeah. So we
Okay.
have a whole knowledge base being able to set different rules, different settings for, uh, if we're going to be doing a drill, setting a certain depth. If it's a further depth, it will do a peck drilling automatically versus just a single depth drill, different settings like that.
Okay, so if we go into the knowledge base and we want to change it, right? You're talking about some of these rules here. So on the left side here, this seems to be all the basic types of hole features: a hole or a counterbore, a tapped hole or a counterbore tapped, right?
I
Now,
don't think we see that page there, Al.
it's not being displayed. Okay,
No.
it's one of the pop-up windows, so that's good to note, right?
Yeah.
Let me see if I can change that. Actually, I'll just keep. It's probably because I'm sharing the software versus the screen, so
Right.
we'll come back to that later. But yeah, there's the knowledge base that you can go in and adjust. What are
Yeah.
some other automatic toolpaths that we have for 2D? So we have holes. We can find them and drill them automatically. What else?
Mhm. I think we just left off before we came in the open pocket option in two axis as well.
Okay, open pocketing. I think that is like an automatic detection, right?
Yeah.
So when we do two axis and we're dealing with geometry selection, this detect open edges, right?
Hmm.
So I get that's kind of automatic. That makes things easier. So you can say work from that side. But the one I was looking for here, Eric, was facing, right? This has
Okay.
been
Yep.
in a couple of versions, but once you've defined your stock in your workpiece, it's automatically gonna face the part off, right? And it will
Yeah.
pick up the depth based on what you've defined. Now, things like keeping the tool on the workpiece, we can use this percentage value to adjust whether the tool stays on or off the workpiece, just by adjusting by how much of a percentage, right? And
Mhm.
then things like adjusting the tool size, we can make this bigger, and then things get adjusted automatically. And because we're talking about start point control, we would also look at the patterns menu here, and this will allow us to adjust which corner we might want to start in, right? So
Mhm.
this is for a facing routine. Okay, so that's in my opinion, this is one of those automatic tool paths that you would want to utilize because you always have to set up your stock. And a lot of times in 3D, we're also setting up our workpiece. Okay.
Mhm.
So we can face things off automatically, and then we can come in and we can drill these holes. And the holes are very helpful because it just minimizes the selection, right? We can select the whole body, we can use filters to filter out larger sizes, and then we're able to program these very quickly. So I know we didn't see the menu pop up, but we can see how the one whole group got drilled here, and then we have the other whole group. Okay.
Mhm.
All right. So facing is automatic. Holes is automatic. What else? It's other things that should be noted, right? Modern manufacturers utilize probing. So
Mhm.
Bobcam's products all include probing, right? So though it's not an automatic function, it's a module that you can get. So if you're running a Haas or similar machine and you want to program your touch off routines to establish your work offset, you can do that, right, Eric?
Right.
Okay. Now, other than just picking up your work offset, what else can you use probing for?
You can use probing for detecting. Uh, Trying to think of the right terminology for it. But with probing, you can once you've done a milling operation, you can make sure the specs are correct.
Okay, so what you're saying is, uh, let's say that, let's say we cut this bore here,
Hmm.
okay, and right now this is just a counter board, so this plate can bolt into the mold, right? But
Hmm.
this could be a critical dimension. So, are you saying with probing we can measure what that size is?
Yep.
Okay. All right. So,
I
again,
believe
I
we
think
can
that would
measure
be,
the z depth, and we could also measure the diameter of it.
yeah, I think that's, great. So just like 2D machining or 3D machining, we create a feature and we edit it. Um, you can also, once you've established a feature, you can copy and paste one. So
Hmm.
that way you can use settings that you had already picked up, right?
Hmm.
So in this case, we're going to select this surface here, right? And we want to use some of these selection tools. So it's control and shift at the same time. Uh, when you pick up edges, this window pops up here, and then we can pick on the different surfaces, right? But in
Hmm.
this case, we're able to pick up from the geometry selection. We get either a 4 or a 3 point bore cycle, and that will go in and measure this, right? So, and we can rename it and figure out what we want to do with that. Now, if I'm using this probe, Eric, and I want to measure this and then I want to update a work offset and then rerun it to adjust for like cutter comp or something like that, can that
Hmm.
be done?
Yeah, so if you're saying you're updating the work offset, your machine setup here, you would just have to update the geometry of the feature and then recompute the toolpath. Is that what you're asking me?
Well, so what's going to happen here is I'm going to cut this part and then I'm going to measure it. And then depending on the size of the measurement, it's going to tell me how much I need to continue to cut to bring it to size. Okay. So I want to automate that process so that I can use the probe to measure it. And then I can take the measurement and then have the control update the offset or have the offset update. So when I run the finish pass again, it cuts it to the right size.
Hmm.
So the answer to that question is yes, it does do that, or it can do that, but it's not an in the box function because it has to write to a variable. Okay.
Right.
You'll notice in this raw text here, we can go in and we can write an output. And essentially, what we need to do is know which variable we're going to be updating on the control. So that's something you can get support from videos from like Haas or also Renishaw, or get training from our team members here as far as how the Bobcat software works. Okay. All right. So that's just a little bit about probing. We did talk about automatic facing cycles, so we can use our stock and our workpiece. And then we also talked about how we can drill these holes out, find them and drill them automatically, right? Okay.
Mhm.
Any other automatic tool paths that come to mind that you would think of right now, Eric, or just curious?
I mean, something that we went over recently with two axes was the rest roughing. We offered with two axis pocketing as well as three axis roughing and finishing as well.
Okay, so, automatically detecting material that's left behind and being able to clean that up. Well, I
Mhm.
tell you what, let's get on the other side of this part here. Okay, so we did some pocketing, we did some facing, we have, or I'm sorry, we just did some drilling and things. Now, does Bobcam support multiple setups?
Yes.
Okay, so how do I add another setup?
So you could right click on that machine setup one and then go to the additional functions
Hmm.
and then insert setup.
Okay. All
It'll
right.
add a
So,
new one, then you can modify it from there.
okay. All right. Now, I noticed that there's some different numbers here, Eric. So I want some help with this. All right. So let's say we set our zero or our work offset on the top of the part here, right? So
Mhm.
this says, when we look at this, it says setup orientation in the coordinate system, right? Okay.
Mhm.
So we established that position. This one here says the work offset number, but Eric, my machine doesn't have 1, 2, 3, 4. It has G54, G55, G56. What?
Mhm.
Why don't I see that listed here?
Yeah, so automatically our work offset number one is G54, two is G55, 56, and so on. If they are different than that, also, that could be in our posting where we can change the.
Customize that.
Sorry, what was that?
Customize it.
Yeah, customize it. Yep.
Awesome. Awesome. Okay, so number two should be because we do 54, 55, so number two should be 55, right?
Right.
Now, it says pick a point here and it has these numbers, but didn't I just set a zero position, Eric? What are these numbers for?
Yeah, good question. So, from what I understand, the work offset X, Y, and Z there, that's going to be mainly for simulation. So, that G55 that you have set up right now, that is
Hmm.
your 0 point in simulation on top of the table. So, to see it a little better in simulation, since it's on the top of the stock right now and will be on top of the table, you'll want to raise it up in Z uh, with that work offset X, Y, and Z. It's not going to change anything in the G code, but it will change the work offset location in simulation.
Okay, so let's visualize that. So what I'm going to do is I'm just going to run this face routine again. Okay. So I'll just have it automatically face off the top of the part. All
Mm-hmm.
right. Now, I only want to look at simulation two. So I want to turn off setup one. I don't want it to be a part of the simulation. Right.
Mm-hmm.
So that's where I'll just click on this controller looking icon and that will turn off that setup. Okay. So from here, I want to go to the simulation button. It's this green play button here, and that will launch the simulation. Okay. Now, does everybody's software come with machine simulation, Eric?
No, so not everyone's comes with this, with the machine simulation showing the full machine here. That is in Machine Simulation Pro versus the standard that is normal to customers. I believe, correct me if I'm wrong, but I believe it starts at 4-axis standard. You do get that automatically on your license.
I believe that 4-axis Pro or greater gets machine simulation, and
Okay.
4-axis standard it's an option. But I think some users will run the simulation, and sometimes they see the tool showing up red, even though it doesn't appear to be anything happening,
Mhm.
any collisions. And sometimes what that is when you have even though you don't have machine simulation, you have a machine with models, and the way that it's configured is it's showing a collision, right? Like this one here, we're right on the top of the table, so maybe it's not showing a collision with the table. But if we come in here and then maybe drill some of these holes, right? Uh, oh, let me see. It seems to be in the wrong setup there, coming from the wrong side. So let me just get another one.
I
I'm just
think
gonna select it.
Yeah, I think probably is referencing those counterbore holes and already thinking that it's gonna go on that side.
The machine, when you're using hole recognition, it will look for your setups for holes. So, so it would find it here, but by turning it off, my expectation is that it wouldn't be there. But we can come back to that in a moment. Let me just get a. a strategy going here. So one of the things that I've noticed, and you notice, Eric, is it takes some time to go through these menus and establish things,
Hmm.
right? What tools you're using and what settings you're using. I hope we have enough time today to get into the templates so we can talk about how to capture and reuse some of that stuff, right?
Hmm.
All right, so let's go ahead and get into the simulation again here now that we've added some whole cycles, and we'll see if it shows it red as it comes into the table. Okay, so yeah, so we see the table is turning red, right? Okay, indicating that we're running into our machine components. Okay, if we turn that off and it's just set into a workpiece mode, you may experience the same thing because there may be a machine model in the background, right? So see how the tool is turning red and you may not understand why. Okay, so that's where if we go back to that setting in the setup here, okay, and we're not talking about our setup orientation, that's your work offset. Okay, what we're talking about is this other section here, and we can use this reference point selection in order to pick a position to align the part. I'm sorry, pick a position to align the part to. I'm way out in space here. So I'm going to just pick this one down here at the bottom, and you'll notice that it will pick up this Z height. And essentially that's what's important here, because when we get back into simulation, now that will be the reference point for the table. So when we look at it on the table, you can see it's from that reference point, so it's above the part. Okay. All
Hmm.
right. So anything else I should cover on that particular topic, Eric?
No, I think that was great.
All right, cool. So let's I really I like the multi-port view here.
Yeah.
I'm still getting familiar. I am using a 3D connection mouse, right?
Hmm.
Okay. Uh which, just like Bobcat, SolidWorks, or Rhino, does support. So that's kind of cool. Okay, so let's get in here. And again, we're talking about some 3D stuff. Eric, what kind of looking at the cavity that we have here, what kind of strategies do you think we should use to machine this?
Yeah. So since the handles, I guess you could say, of the mold shape, you can since it's a flat floor surface, you could do like a two-axis cut with that, and then be able to come back with a three-axis milling for the rest of it.
Okay. Um okay, so we could do some 2D machining and combine 2D and 3D machining. What is, one of the things that we deal with tooling is we deal with harder materials, right?
Hmm.
So, when the tool enters the material, it's generally the hardest on it, right? So, one of the strategies to minimize that is to drill like a pilot hole. Okay. So, if we wanted to drill a pilot hole in these cavities, for the tool to start in when we started roughing this in 3D, what might we do there, Eric?
So from the start point option, from what I understand, we do have that start point control option, like the drill. I go to my screen here for a second. The thing is called start tooltip, or no, tooltip
Mm-hmm.
position.
Mm-hmm. Yeah. So what we're talking about here is this tool drill tip position.
That's it, drill
Okay.
tip.
And being able to use this, basically drilling a hole and then having the tool start in that hole for the additional roughing routines, right? Or the additional step downs. Okay, so we're going to go ahead and select our whole model here. So we'll say select whole body, pick the body. Okay. And then we're going to go in and double click to edit the operation, and we'll adjust our tool, right? So we're going to go down to like a 3/8 end mill. All
Mm-hmm.
right. From here, we're going to use a basic offset out strategy. So this would be a light depth of cut with maybe a more aggressive step over. So, maybe a 50 thou or 100 thou or something like that with, maybe greater than the radius of the cutter step over. Okay.
Hmm.
So, so those are our settings for our roughing. We'll go ahead and compute this, and we're going to see, we'll get some toolpath on the screen, right? So what's one of the things that you notice right away, Eric, that maybe we would want to avoid?
Um.
So think about it. On this side, we drilled these holes and cut them out. Now we flip the part over and we're on this side.
Hmm. Are you saying to avoid the holes that we've already cut?
Correct.
Yeah.
Yeah. So we already cut those holes, so we want to avoid them. So how could we avoid them?
When we're creating the boundary, we can make sure to avoid
we
to
could
select
we could
those
select the
areas.
boundary. Right,
Yeah.
right. So we have our feature here. It's associated to our part model, and then we have an operation. This is our roughing operation, right?
Hmm.
Okay. So now it's cutting in areas that we don't want. So we want to control that. Okay. So one of the ways we could do that is how? With a boundary, right?
Hmm. Hmm.
So we could, go to the boundary and choose reselect. And then we're going to hit control shift and left click on this edge here, and we'll pick up this boundary. So we can say, okay, stay inside of there. And
Hmm.
then so the toolpath didn't change. Why didn't it update?
Sorry, I didn't see. Did you select a
Yeah, I
boundary?
selected a boundary. Why didn't it just, you know, all of a sudden update all the toolpath?
Right. So we have to define to compute the toolpath again.
Compute it, right. So we
Hmm.
made a change, and then now we want to update for that change. And the change was just adding the boundary,
Hmm.
right? So now we're just limiting it to this section here, right?
Hmm.
Okay. Now, so one thing we're talking about is controlling where we're cutting, and we did that with a boundary. For bonus points, what's another way we could maybe limit some of this, limit where it's cutting?
You can set a certain depth you want to go down to, or where you want to start at as well.
Okay, I think that's great. We'll go into the feature and parameters, and then you have your depth settings. So we could say start cutting from a certain position, right? Or end cutting in a certain position. So
Hmm.
that's good. That would cover if we're trying to restrict it in Z, right?
Hmm.
In this case, we want to restrict these holes. So we talked about a boundary. The boundary method, we could come in and just pick all the boundaries to the cavity that we want to work with. We could prep this by putting these boundaries on a different layer or creating entities on a different layer. And in that way, we could just select it, right?
Hmm.
So we could use boundaries to contain it. But what's another thing we could use? We could also use the stock geometry. So we could adjust the stock geometry either just by adjusting the size of it, maybe, making it smaller, maybe 8 by 8, is the area that we want to look at. Okay. So if we remove our boundary and we recompute, now the software is going to look at between that 8 by 8 area or wherever that stock is. Okay, so we eliminated these holes, but now we have it cutting from the outside there, right?
Hmm.
Okay, so that's kind of where you were talking about too. This will help show that Z value. So
Hmm.
if we go in here and we say, all right, we don't want to go any deeper than a certain amount, you can pick off the geometry. It will measure that depth for you, and then you could also adjust, make this number or enter that number. So, and essentially what we're saying is we're limiting in Z now how far we're cutting down. Okay.
Hmm.
And you can see where it will leave material on the bottom there. But I don't think I think the boundary method would be the best here. There is one other or probably a few others, but we could adjust our geometry too. So we could generate a cap surface if we didn't want to adjust the stock. We could leave the stock as is, right? Just by doing that, it will eliminate that outside cutting. But again, it's picking up the holes. And then I'm not as familiar with their surfacing commands in here. Basically, I'm just looking for a planar one from a boundary,
Mm-hmm.
surface from planar curves. So we would pick those two curves and hit enter. This in this is true for, okay, I think if, let me go back to it. There's a way to go back to the same command in Rhino that makes it really quick, but you can go like this, and then enter. And so you can see how we're capping off these surfaces. I would use this same cap method in any uh, CAD CAM system, right? I'm going to select multiple this time, where you can add a surface, and by adding that surface or surfaces to your selection, you then can restrict the tool path, because it then sees that surface as part of the selected geometry, and it will stop it from going down in those holes. Okay.
Looks
So
good.
now, just by adding those surfaces there, you can see that's another way to do it. For me, anytime I usually do this on a different layer. Rhino isn't any different. You can just create a new layer. You can make the layer active. Moving geometry to a layer in Rhino, I'm not as familiar with. I'm just going to try selecting them all. That didn't work. Uh, but it doesn't matter. This isn't a CAD demo, but you can use the layers and then turn the visibility of the layers on or off, just like you would in BobCAD. SolidWorks doesn't really use layers; it uses features, so the way you navigate that is a little bit differently.
Mm-hmm.
But I digress. Okay, so we use boundaries to restrict, we use stock to restrict, and then we also use geometry to restrict. Okay, if we get back into this particular cavity here, we were talking about 2D and 3D machining, and you can combine 2D and 3D machining. You were talking about just doing 2D machining on the shoulder here, right? So we just want to come in and cut that pocket. Um, that's just like any other 2D type routine. We'll start the 2D wizard, select geometry. If we just pick that face, it will say okay. As far as setting what the depth is, we can pick it up off the geometry or enter it. Okay. We'll come in and we'll load a pocket and a profile. The tooling size, we're going to just type what the tooling size is. I'm not sure. I don't remember exactly what fits in there. So we're going to just make it a 1/4 inch, and we'll compute, and we'll see we get the tool path restricted, staying within that boundary, right? So we can back plot it and see that it's staying within that boundary. And that's what we would expect for a pocket, correct, Eric? That's what
Right.
you would expect for a pocket, is for it to stay within its boundary.
Right.
Now, you could add other boundaries to it, right? So we could add multiples to it. You're not limited to a single surface. Um, Technically, we're using single surfaces as boundaries, right?
Mm-hmm.
But it has this open area, and in the past, we would have to create additional geometry to handle that open area, okay? So like you were talking about, we would go to the geometry selection and turn on this detect open edges, okay? And then now it's supposed to magically work, right? Well, why didn't it work, Eric? What's going
Um.
on? This is going off the edge and this is staying inside. What's happening?
Well, do we have the advanced pocket?
That's a good answer,
Mm-hmm.
right? So, what pattern are we using?
Yeah.
So, if we go to patterns, our standard patterns do not support the open pocketing, do they?
Right.
Okay, so we got to go to the advanced ones and then pick one of these, and we'll choose the cool adaptive, because who doesn't like adaptive machining, right, Eric?
Right.
When you did that, the demo part we did in house, did you do adaptive facing, or did you do the traditional facing?
The demo part in house.
Yeah,
Which
the
one
one
was
that everybody drew and then cut on the yellow machine.
that? Yes. Yeah, I did do an adaptive
You did.
machine pocket on that. Yeah.
Cool. All right, so that's the adaptive
On the right.
routine to come in there and to rough that out, right? The other thing we see here, this is the profile finish, right, to come in and to finish that wall. So we'll notice that the profile finish also noticed the open area. Is that correct?
Right.
Now, if I wanted the profile finish to start out further off that edge, what would I do, Eric?
Yeah, you could set a different lead in so that it'll start a little bit further in.
So I could adjust the lead. Right now it's set to a vertical. So I could do maybe a parallel lead in, right, and lead out, and that would adjust that. There's those leads. Is there another option I could use to adjust the lead or length of a profile?
I'm not sure if we do. We I don't think we have a drill tip position, do we, or anything like that?
Well, we do have this feature extension, and this is pretty
Okay.
important for 2D geometry. Okay, so if you want it to extend out further, you can either use a percentage or a value here. Okay, and this can be a positive or a negative number, so you can have it extend or you can have it trim back, and that can be very helpful in order to avoid different features at time, leaving material behind to work as a tab, or just to gain clearance. Okay. So, all right. So that's kind of cool. Open pocketing, it detects the open area through selection, the profile finish. We can use extensions to get it to start off. Further, I think there's another thing in finish here that's important to notice, is the spring passes. Eric, why do we do spring passes?
Um, from what I understand, to do multiple passes to at the same level, just in case there's any extra material.
Right. So essentially, when we're on a finished pass, we've roughed the part, we're coming in and we're finishing. There can still be deflection in the tool, so we'll use spring passes in order to assure, like we may take two passes in order to ensure the deflection is taken out of the tool and we get a final size that we want. Okay. So we can, previously, in order to do this, you would have to come in and copy and paste multiple finish strategies in order to do a spring pass, and the tool would go up and down the clearance in between each of those. Okay, so now you can just tell it the number of spring passes you want. Okay, you turn this on and you say the number of passes, and then you have some options of whether it uses the lead for the spring pass or not. Okay, and again, if you're just jumping in with us now, we're kind of at a halfway point here, or a little more maybe. Um, you know, all everything we've shown here today applies to all three products with their new Omni development. All the software is on the same release schedule. So they all have the same functionality. So if you see it in one, you'll see it in the other. The only differences are going to be the CAD environment, SolidWorks for SolidWorks, Rhino for Rhino, Bobcat CAD or Bobcat for Bobcat Cam for Bobcat, right? Okay, so it's just your CAD environment, your selection tools. Other than that, um, the cam is the same. So if you're seeing spring passes here, you'll see it in Bobcam V10, V35, and V3 here. All right, so that's a little bit about the spring passes there. Um, okay, let's go ahead and let's get rid of this two axis feature. I see Bob is getting really excited about this extension function that he wasn't aware of. And it's true. In the last three versions, we've added over 200 new features in the software, many of which goes unknown because of lack of knowledge. So we really do want you guys to read the blog posts, to attend the training events, to use your online training so you really maximize what's available in the software. If you're not sure what's included with your membership plan, please call us today, 727-442-3554. Ask about the Advantage Plan memberships, what's included, how to add or update your existing account. Okay, now, Eric, we got this 3D routine here. We've restricted it via geometry in this example. We have this shoulder over here, right? A
Mm-hmm.
couple of things we want to talk about: how we're getting into the part, and then also machining the shoulder. So, how do we ensure that when we're roughing this out, that we're roughing out this shoulder as well?
Making sure that we have the right size tool to be able to.
That's a really good point. Let's bump this tool up here to 750 and recompute. Okay, and then all of a sudden the tool path doesn't fit in there. Why is that, Eric?
Because the diameter is too large to be able to fit into that kind of groove area there.
Okay, so is what if I want to use the larger tool and I want to use a smaller tool to come back and finish where the larger tool didn't go? Can I do that?
Sure, you could do another operation, and we have that rest machining option to finish up exactly where we left off.
All right, so we go edit the feature, right? That's the feature. So
Hmm.
we go and edit it, and the wizard comes up, okay? And then from here, we go to our strategies. So this is everything that's available. And you're saying that if I add another advanced rough, right, I can use this one as a rest roughing routine. So I'm going
Right.
to drop the tool down. I'm still going to use adaptive, right?
Hmm.
How do I know it's rest roughing? What am I looking for? There's all these menus, Eric. Where do I go?
Yeah, so under the options page there, we have the checkbox at the top that says rest roughing.
Oh, okay.
So if we check that, it actually uses the previous operation automatically. If you uncheck use previous operation, you could set your own tool that you've used to go off of.
So, you know, great point here. It automatically picks up the previous cutter, but then we can also adjust the previous cutter. Now, one of the ways that I use this is if I want to get a little more overlap, because the software's got to do some math to figure out where material is left, right?
Hmm.
So if I adjust for the size of the cutter, basically I'm saying I can say there's more material left. So if there's more material left, it's got to cut more, and it's a way in which I can control that or adjust that. Okay. Is there any other ways to feed it material for a rest roughing routine? Like, what is there another method that we could use, Eric?
We do have the operation stock option.
Okay. So if we're in the tree here and we're under an advanced rough routine, we do see operation stock. And I believe what we're saying there, Eric, is we could select a body and use that body as an in process stock and then trim against that body for your toolpath. Is that correct?
Right. Yeah, so
Oh,
we're letting the software know exactly how much material is remaining with our operation stock where we're left off of, and then run an operation based on that operation stock there.
so, I think that's a really cool feature. Another thing that I think is really cool is this rest roughing, right? Where we have an operation and then we're coming back and we're re-roughing with another tool. And I believe that, there's a series of tools that you would use in order to step down, and setting those up and being able to reuse them in the future probably would help you save time programming. What do you think, Eric?
Yeah, I agree for sure.
Okay, so how well we'll come back to that. Okay, we'll come back to that here in just a moment. Let's kind of look at this again. Let's get rid of this space routine here. Okay, so if we want to get something out of the tree, we can just delete it, right? We want
Hmm.
to get rid of this setup, we can just select it and delete it. Okay, we have this operation, we have these two tools here. Okay, uh, one doesn't look like it's really machining all the way to the bottom. The other one doesn't necessarily look like it's really cutting on that shoulder there, Eric.
Right.
What am I doing wrong? Why? So I'm not as familiar with navigating in Rhino here. So let's go to one of these front views here. This looks a
Hmm.
little bit better. Okay,
Okay.
so when we look at this line here appears to be the shoulder or the floor, either
Hmm.
the top of the radius there or the floor, and you can see this is above it.
Hmm.
Same thing here. You can see this one's above it. So why isn't it cutting all the way down to that bottom area there, Eric?
Yeah, so easiest way I can try to describe it is that our depth of cut is not what I normally say is the number that we've set is not divisible by the actual floor depth.
Yeah, exactly.
Yeah.
Yeah. So, okay. So we set a depth of cut and our shoulder doesn't match up to it or our floor.
Yeah.
Is there any setting we can use to say, hey, make sure you cut on that floor? I don't care whatever my depth of cut is. Make sure that we cut on that floor.
Yeah, so on the options page, if we go back to that, where we have our rest machining option, we do have a checkbox below that for machine flatlands.
Okay. So let's turn that one on.
So that basically just does an extra pass on all of the floors in case we haven't gotten to those with that depth of cut we have.
All right. I don't know. Didn't like something there,
Uh-oh.
but that's okay. Let's see if it does it again.
Said something about rest roughing, I believe.
I'm not really seeing anything wrong here. I'll turn that one off for now. That's all I changed, and we'll come back to that later. All right. Let's so we talked about some roughing. One of the other things that I was talking about here was using points as our lead position, right? So we said
Mm-hmm.
drill tip position. Okay, if we go to our roughing routine here and we go to the leads, right now it's set to plunge and it's center cutting. We could set it to ramp, and these are just different methods in which how it would get down in there, right? So we set that value, we recompute. Now we're going to see the tool will ramp as it gets down into the pocket from one level to the other. Our goal here is to drill a pilot hole in order to work with. Um, One of the things I'm not, like I said, I'm not as familiar with designing in Rhino, so some things are a little more painful than others. But what I want to do is just draw a point, but I know I need to draw a point at the Z position. So drawing a point isn't hard. I can just, come in here. I should be able to wake up some of the geometry, but I really want to make sure that I'm grabbing these points that's on the floor, right? I need this center point that's on the floor here. And so it's kind of in Bobcat, I would adjust a UCS is how I would do it. We
Mm-hmm.
can see we got that point there, but in this one, I think you have to adjust your C plane, but I'm not sure where the C plane is or how to adjust it. So again, this is why CAD is so important. Something as simple as just drawing some points is helpful, right? So what we're going to do is just go to the top view here, and I'm just going to draw it in this method, see if I can get something where I need it to be. We probably could extract edges. That's probably another method to do this, is get some edges down there on that floor.
Yeah.
And then that one, I feel like I missed it. It's painful. It's painful, very painful. This must be what it's like when people are watching me do CAD and Bobcat, right? All right, so we'll just get a couple more going here. And really what we're trying to do is just establish an XY position for our pilot hole. And that's it. Okay, so we have some point locations here. We're going to come back and we're going to say drill hole, and we're going to select these points, right? So that one, this one, and this one. Now you'll notice when we do the point selection, we have ignore Z, use as top, or use at bottom. Normally what I would do in this case is draw the point at the Z level I want, and then I would say use as bottom. In this case, I'm just going to choose ignore, and then I can just type in whatever depth I want it to go to. All right. I need to add an operation to it, so I'm just going to remove that center drill and just put a drill in here, and we'll compute. So what I've done at this point is just added a hole in the center of this. And what we're saying is we want to drill this pilot hole for the tool to start in. And then from there, we want the 3D routine to to pick up that point. Okay, so we drill the pilot hole. Now we need to select those drill tip positions in order to for the software to know where it went to in Z. That's what they use. That's why it's called a drilled tip position, so it knows how far you drilled in Z. Okay, so we select those points. Um, when we recompute now, it will use that reference point. So it's of there for all of these holes, okay, down to the Z depth that we told it to go to. All right. And then I believe the new feature here is that it will ramp at those positions. Previous versions, if we set this to lead and we have it to a spiral, right? It should pick up these positions and spiral from that lead position. In previous versions, it wouldn't do the spiral. Okay, so that's an update that happened there. I don't see it doing the spiral here, but I do see it starting from that lead position. What I want to do is visually verify what's going on, so that's why we'll load up simulation and take a look. Okay. Now, if there's any features, functions, questions you guys have about 3D machining that you would like us to cover, please just ask in the questions here. Even though we may not answer it in this event, we definitely will pick it up in a future event. A big reason why we hold these events is to work with customers or potential customers like you and to get feedback. So please attend and respond. That's the most important part of us being here is for you. So here we can see we drilled the pilot hole, and then we can see that it will start in the center of that pilot hole and then work its way out. Um, once we get it done doing that, we should have like a rest routine that will come in and then re-rough where those shoulders are, and that's the process that we're at right now. Okay, so Eric, we're at like 2:20 right now. What kind of
Mhm.
timeline are we working with today?
It's normally 1 to 3.
Okay, 1 to 3. I want to give the users back a little bit of time. So what I'm gonna do is I'm gonna just show the templates real quick because we covered some topics here. But essentially, what we're talking about is we want to drill some pilot holes. We want to do a roughing routine, and then we want to do a rest roughing routine to clear where the other material came from. We want to call this our standard process, and we're doing this for our mold cavities. So the templates is one of the things that you can do to capture and reuse settings that you have. Eric, in order to save a template, what do we need to do?
We can right click on the milling job there and then go to Save as Job Template. And then
Okay.
we can name it. And then that's about it. Then it's referenced for next time when we want to create a new milling job
All
or a new.
right. So I'm going to open up another. I'm going to open up another file. This one is going to be this one here. Okay, so here I have another model that I got from engineering, or it's basically a very similar type part, but it's a little bit different. Okay, so, but you'll notice it's a similar size and it has similar cavities, and really that's the idea of templates is being able to cut similar parts or projects either by the machine or by the type of work you're doing, right?
Mhm.
So, what do I do to load that template in here?
Then you can just right click on the cam defaults there and then new job from template.
Okay.
And then you'll select from the drop down there the name that you created for it.
Okay. So when I do a new job, what doesn't come over? It looks like some things came over. What do we know? Does anything not come over, or are you unsure on that?
The only things that I know of that don't come over are the stock that we have to reselect. If
Well,
it's going
no,
to be
we
a
have the
different
stock.
size.
Yeah, it
Well,
picks up
yeah,
the stock.
it picks up the stock from the previous one. So if it's a different stock shape,
I
you'll have
see what
to.
you're saying.
Yeah.
So okay, so I import this template. It's the stock did come over, but I may need to update it because I have different size geometry. Okay. The zero comes over, right? But maybe I want to be in a different orientation, so I might adjust that.
Mm-hmm.
Okay. Do the tools come over? Yeah. Okay. So the tools come over. So that's useful. I got all the same tools I used from the last job. My machining features came over. Their settings. So yeah, it looks like speeds and feeds, all that stuff is going to come right over, right?
Hmm.
Okay. So we want to drill these holes. So what do we need to do?
There's a
Because if
Yeah, so we have to reselect the geometry. And one thing Bob just pointed out is to check your tool numbers. Do we have the same tool numbers in the tool creator?
I used automatic numbers, right?
Mhm.
But it did pass over the database number. So whatever tools I had, tool numbering that I had established, it would pass over. I believe that's the case.
Okay.
But thank you, Bob, for drawing some attention to that because I know that there is some new things we've done with tool numbers. And automatic numbering. In the past, Bobcat was always defaulted to automatic numbering. That was difficult for some people. Bobcat now has the option to default to either automatic numbers or not. You can turn off automatic numbering as a default. How do you
Mhm.
do that? You go into the settings somewhere, and I don't know exactly where it is. So maybe we have a. Okay, here it is. So we have so we have system
We don't see
cam.
that. We don't see
Oh,
that
you can't see that
window.
window because I'm not showing it. Let me see. I'll have to. I'll do that next time. Remember to share the whole screen.
No worries.
Uh, Let me see if I can do this. Screen. This screen. How about now? Okay, we can see it now.
Yep.
Okay, so let me go back to that. Sorry about that, guys. Okay, so we'll go over here to settings. We're going to go to cam and then document. Uh, So you have the current document and the default. Okay,
Mm.
so we'll go to the current document and adjust it, or we could go to the default so every new document would have it. But I'll go to the current one and I can say milling job is automatic tool numbering or manual tool numbering. So you can default it right here, Bob. In the past, you could not change this. Now you definitely can change it and default it to manual tool numbering if that's what you prefer.
And as a
Very
side note, with a standalone version, you just go to File and then Settings, and it's on the same page here.
perfect. So, and then I'm sure with SolidWorks, you'd be in the same boat. The help thing looks like a question mark over here or something. I don't know. I don't have
Yeah.
SolidWorks open right now. Okay. All right. So let me go to this 2D view here. Okay. And we're gonna do the point thing. And actually, I'm gonna try this differently this time. I'm gonna do it this way. I'm gonna do render. I'm gonna add a new layer. I'm gonna make that layer active, and then I'm gonna do extract something. Extract curve, mesh. Extract wireframe. Let's say that I don't really want all that. Um, can we do just one of them? Okay, no. Let's do escape. All right, let's try one more. I'll do extract. I know it. Mesh edge. Let's try that. No, this isn't a mesh. Um, let's try that. All right.
There you go.
I forget what command is repeat. Oh, okay, it's right mouse button. That's awesome. Okay. So you can do right mouse button, left mouse. Let me try it again. Right mouse repeat this. And then, yeah, that was it. Oh, I just have to click enter. Right mouse, left click, enter, enter. I don't know. Okay, whatever. I have two of them. We'll do two. How about that? So now I can turn that off, and I can just say point. This should be able to go there. Do another one there. Right click there. Okay, so now we have those points. Now I'm going to select these points. Right? I'm going to say use as bottom because they should be at the Z depth that I wanted. We'll say okay. All right. This one will compute, and then that should drill the holes the same way the last one did. Okay, same tool, same speeds and feeds, same settings. So that's our pilot hole. Now for this one here, we're going to just select our geometry. We'll say the solid. We'll pick that. Okay. Boundary, we're going to select the boundary for it. Again, this is Control and Shift at the same time. Left click on the edge, pick the boundary surface. Okay. It's actually pretty quick to do this. And I think it would get even better if I actually used it more often, right? Drill tip position, we'll just turn off the model and window pick these. We'll say OK, and then we'll compute. That's going to give us our roughing routine starting in that center hole that we had picked. And then this is our rest rough routine where we're going to come back and remachine where the other tool wasn't able to go. So just a quick example of how you could set up a template and be able to utilize it to speed up your programming. Now, we were talking about this morning, weren't we, Eric, about how much this can actually speed you up? Do you remember some of the numbers we were talking about?
Some of the numbers I'm trying to remember. Um,
It definitely could have a big impact. What kind of impact do you think this could have on people's programming time? What do you think, Eric?
Sorry, with the rest machining or with what in
The
particular?
job templates.
Oh, the job templates. Yeah, I think this morning you were talking about 90% efficiency there, being able to cut down on cycle times. I mean, if you're going to be creating many milling jobs with the same style of geometry, same style of operations, you don't have to do them all again. You can just templatize everything and run it from there.
Yeah, I think 90% was what some people said. I'm sure that there's a certain amount of finesse that you have with each of your operations. But in general, this is why we want to use standardized settings, standardized workflow, standardized tooling. Bob says templates are extremely useful. I definitely agree. There has been a bunch of things that were added in there. The last thing I kind of want to touch on, Bob said 90% for sure. Good feedback.
Good.
The last thing I kind of wanted to touch on here before we'll call it for today is the operation tree and the tool tree. Okay, these are very important and very new aspects of the software. The operation tree, this and its tools is what replaced the machining order dialog of previous versions. If you're not paying attention, you will be, because this is how you change the order of operations with posting. So if you wanted to move these, it's the whole new interface. It's way better than before. Multi option, select and drop, and editing, and a bunch of stuff. So we're going to definitely spend some more time on this, just not today. The other one here is the tool tree. This is also a really cool way to make adjustments and changes to your software. Um, and your programs is really what I mean. So if I want to edit all the operations that utilize this particular tool, I can come in here and decide to make a change for that cutter, and it will update all the operations associated with that cutter. Okay, so this is again a new way to edit. And it offers a lot more control. So something you should be looking out for and definitely utilizing more. Is there anything else, Eric, you might want to touch off on before we cut everybody loose today?
The only thing I could think of, speaking of templates and uh, patterns and things like that, I was thinking of the toolpath patterns and the work offset patterns as well. If you wanted to touch on that today, if not, we could do that next
Yeah,
week.
I think there's some really cool things that we've done there for toolpath patterns and work offset patterns. But I think the thing that is important to understand is the big difference between the two of them
Yeah.
and where they're located, right? So
Mm-hmm.
if we go to the machine setup and we go to work offset pattern, right? This is what the dialog looks like. And work offset patterns are when you're trying to make copies of part of your program or a complete program, but you want to post it in different work offsets. So the same part in 55, 56, and 57. Okay. That's what work offset patterns are for, and that's where they're located. The other one is called toolpath patterns. And toolpath patterns are when you're in a single machine setup. So you're all in 54, and this is where you want to make a copy or another iteration of your toolpath. Now, something that we've done here recently that has a big impact on this particular feature has to do with that new um, operation tree. Okay, so this is the toolpath pattern, and this is the original, operation. Okay, so we program this operation once, and then we use the pattern to make copies. In this case, we're doing an array. You can adjust what the distance is between that. This is very helpful when you're trying to minimize calculation times, and especially if it's a pattern repeat, strip style machining. You program it once, and then you use the toolpath patterns to make iterations of it. And then there's a variety of different styles. This method you use when you're within a single work offset. Okay. The other method we use when we're in the machine setup, this is when we're doing a work offset pattern. This is when we're dealing with multiple work offsets, 55, 56, 57. Okay. What I want to draw attention to is the operation tree will show all of the pattern instances. Okay, so this is for toolpath patterns. Okay, when you do a toolpath pattern, their instances will now be listed in the operations manager. And even better than that, sometimes you need to one, two, skip a few, 99, 100. You now have the ability to go to individual operations and turn them off. And you can reorder the posting order of toolpath patterns. This is a big game changer for anybody doing horizontal style machining or when they do copy and iterate type routines like this. Okay, so
Mhm.
we'll spend more on that on a later date. I do want to remind everybody to make sure to take the event topic survey. If you got an email to get you here today, make sure to take that event topic survey so we know what you're most interested in and what topics to cover next. Right now, we're working on Rhino V3. I believe next week is the advanced milling webinar. Is that right, Eric?
Yes,
Okay.
I believe so.
Uh, yeah, I believe it's advance, which will probably get into surface based in 4 and 5 axis or touch on it at least. And then also following up from there, I think we're going to do just a 4 axis specific training session and kind of more so for like woodworking, like columns and spindles. I think that would be fun, don't you think, Eric? Like wooden columns and spindles and that kind of thing?
Yeah, definitely. I think a bit of a change for us with the different uh, trainings that we're or webinars that we're doing, and being able to help with our huge base there with woodworking. A lot of customers that do that.
Yeah, Eric does the demos here. So if you are not a current Bobcat customer, it's likely you'll talk with him for a product demonstration. I just want to direct you guys to a couple of places on the website. We are making updates. If you're looking at getting started with any of the Bobcat products and you want to see the getting started videos, just go under the video section there and you'll be able to see it. It looks like I'm logged into the website right now. You'll see the first item on there is the getting started videos for all of the products. So you can go there. The other thing that I wanted to talk about was the Launchpad classes. Okay, so these are the getting started videos for 35. V2, V3 will be out shortly, but essentially the getting started is the same, just in the different CAD packages. So if you are transitioning to this software, I recommend you start with those. Now, the other things that are very useful are these fundamental classes. They may be part of your membership, they may not. You're going to have to call and talk with your account manager. We have milling CAD CAM fundamentals. This is great. It covers all the basic 2D and 3D things that you would want to get into. Uh, Good for transitioning new users, upgrading users, cross grading users. this is a great place to go. A lot of people run mill, so I highly recommend the mill fundamentals. Now, we also have a lot of lathe programmers as well. This is the lathe fundamental courses here. Teaches you about grooving, OD, ID, facing, tooling, roughing, semi-finishing, and finishing. Everything you need to know for two-axis turning. I definitely would recommend considering this course if you're programming a two-axis lathe. The most newest fundamental course is the mill turn fundamentals course, combining both milling and turning on one machine. If you're running a C-axis, um, maybe CNY axis type mill turn like a STY or something like that. Uh, these classes are going to be great for you. Get a jump start, take them now, and get ahead of the curve. I do recommend that you take the mill and lathe fundamentals first before you take the mill turn. The last one I want to talk about is the post processor and machine definition. This class or series of classes, great. Anybody who considers themselves a professional CAD CAM programmer should know how to edit your machine and post processor. And these classes are what teach you how to do it. Okay. So you definitely want to take this 1, 2, and 3, especially for all of our 4 and 5 axis users. Now, Bobcat will develop your posts for you, and many of your packages include posts. As you get up into the 5 axis, there are some costs associated with the post, but below industry standard by far. Most companies charge more, sometimes even more than $1,000 an axis. So you're still getting a great deal on posts with Bobcat, but take the class to learn how to do it yourself. Eric, where do they go to see the uh, the schedule? The schedule is
It's,
under Bobcat support, right? And then
mm-hmm.
it's the virtual training schedule here.
Yep.
And this is all the current events. You can even see the current one playing, and then they just click there to join. So those are the topics that I have. Again, our phone number is 727-442-3554. Give us a call. It'd be great to talk to you. Eric, I know you want to do some demos, don't you?
Yeah, definitely. Anything you guys are interested in looking at, any new modules, let us know, and I'd be happy to schedule something to view on my screen here, just like we did today, in depth on anything you guys are looking to upgrade to.
Awesome. Well, that's all I have for today. I look forward to seeing you guys next week. And I don't know, Eric, wrap it up.
All right, thanks, Al. I appreciate your help today. Doing, kind of going over everything with the 3 axis. We're going to be going over 3 axis Pro next week, on the same website there, to be able to look at Bobcam for Rhino version 3 is our schedule for the next few weeks there. And thank you everyone for viewing our webinar here, and hope you guys have a great day.
Awesome. Bye now.